Good afternoon. Good afternoon. Hope all is well. Everyone's doing all right. We'll give it a few seconds, make sure everybody's in that's coming, and then we'll get started. All right, so we have the sum and difference formulas. Hey, you guys can go ahead and get started. Let me hook this up to TV. We have cosine of the difference of two angles. I can write that a little better. I'm gonna hook you up in a second. All right, there we go. No hiccups this time. All right, so we got a cosine of the difference of two angles. So that's cosine of alpha minus beta. That's going to equal to cosine alpha, cosine beta, plus sine alpha times sine beta. I'm scrolling up a little bit. So in the green is the problem. Find the exact value of cosine of 15 degrees. Now, if you were to throw cosine 15 degrees in a calculator, you are going to get a decimal value, but the key here is find the exact value. So what we're going to do is use the cosine of the difference of two angles to rewrite what cosine of 15 degrees is and use familiar angles. Remember, we have our familiar angles, 30 degrees, 45 degrees, 60 degrees. So we want to be able to rewrite 15 in reference to that. So notice what I have here rewritten in the red. You can rewrite the cosine of 15 degrees as 60 degrees minus 45. 60 minus 45 is still 15. But if we use that relationship and then use the difference of two angles, we can rewrite it in the way that we have the blue. In the blue. Letting 60 degrees be alpha, 45 degrees be in beta. That means we'll have cosine of 60 degrees times cosine of 45 degrees plus sine of 60 degrees times sine of 45 degrees. So from there, you will use your exact values for the cosine of 60 degrees, cosine of 45, sine of 60, sine of 45. So remember, I gave you a chart last chapter, and then I also gave you that unit circle. So that's where you'll pull the 1/2 square root of 2 over 2 and the square root of 3 over 2 from. So that's 1/2 times square root of 2 over 2 plus square root of 3 over 2 times square root of 2 over 2. Multiplying those together, that'll give us the square root of 2 over 4 plus square root of 6 over 4. And then if I want to write it as one whole term, I have my common denominators. Just bring them together, square root of 2 plus square root of 6 over the square root of 4 would be my most simplified way of expressing that answer. Questions before we go to the next one? Everybody good? Yes. Mhm. Like this one? No, that wouldn't be wrong. It just wouldn't be the most simplified way of expressing it. You can try the math lab, see what they say. They may just say, this can be simplified further. You know how to give you that little hint. But if math lab ended up marking it wrong and you told me, because whenever you take a test, and this is for anybody, so most definitely, I'm talking to the whole class here. Whenever you take a test and you always go back and check your answers. I don't know if I made this announcement or not, but always go back and check and make sure that your answers are correct. Math lab didn't mark it wrong. Or, for instance, it is looking for a certain type of answer, a certain way. So if you write x equal to 2, but all it wanted was the 2, it will mark x equal to 2 wrong. But you did get it right. So, but I wouldn't know to go in there and adjust your score unless you tell me. So you always go back and look. So if you put in this and they marked it wrong because they wanted this, then it's just letting me know and I can go back and adjust that. So yeah, if you got that far, I would give you that. Mm-hmm. All right, so the next one, find the exact value of cosine 80 degrees times cosine of 20 degrees plus sine of 80 degrees, sine of 20 degrees. So notice this one actually is going to work in reverse of what we just did. So I can rewrite this as cosine 80 degrees minus 20 degrees. 80 minus 20 is 60. And now the cosine of 60 degrees is 1/2. All right, any questions before we go to the next one? All right, so the next one they ask us to verify. Remember I told you from last class, they could use these relationships to do a verifying as well. All we're trying to do is prove that the left side is equal to the right. So we have cosine of alpha minus beta over sine alpha cosine beta equal to cotangent alpha plus tangent beta. All right. So I'm going to work with this side over here just because, we just got this whole string of what cosine of alpha minus beta is equal to. So I'll rewrite that numerator, cosine alpha cosine beta plus sine alpha sine beta. Next, don't forget, no matter how complicated your denominator is, whatever's in your denominator has to go to each term in your numerator. And your terms are separated by the plus and minus signs. So we have 2 terms in our numerator. So in other words, if I had 5 plus x over 2, this 2 has to go to both terms if I want to break it up. And so that's what we're doing here. I have sine alpha cosine beta in my denominator, and I'm breaking it up by sending it up to both of those terms. All right, well, trying to trigger the lights, but it's all good. So now we have cosine alpha cosine beta over sine alpha sine beta plus sine alpha sine beta over sine alpha cosine beta. And then you notice that my cosine betas cancel in my first term, sine alphas cancel in my second term. That leaves me with cosine alpha over sine alpha plus sine beta over cosine beta. And then if you rewrite them in a more simpler form, that's cosine alpha plus tan beta. And that will be your answer, or your proof, your verification. All right, any questions, any questions? Think about scheduling in my head. All right, so let's look at some more sum and difference formulas. Number two is the one we just finished dealing with, cosine alpha. I just went ahead and wrote it with all the rest of them, so you have them all in one spot. Where you got the sum, the cosine of the sum of two angles, and I said the cosine of the difference of two angles. Then we have the sine of the sum of two angles and the sine of the difference of two angles. And so notice all of them are similar but slightly different. Difference between the cosine of the sum and the difference. That one has a plus, the other one has a minus. Same thing when it comes to sine, but then they switch up. You know, you got sine alpha, cosine beta, cosine alpha, sine beta. All right, we good with the copying. All right, so next example says find the exact value of 7 pi over 12, and they tell you to use the fact that 7 pi over 12 is the same thing as pi over 3 plus pi over 4. So basically, they're telling us that we're going to have to use relationship 3 because they give us pi over 3 plus pi over 4, and we're using sine. So we have to use that third relationship. Is everybody done with the black? Everybody good? Everybody good? Okay. So the process is still the same as we did in the first example. It's just that you just have to make sure you establish what pieces is what. Like I said, they gave it to you here. So that means pi over 3 is going to be our alpha. Pi over 4 will be beta. And then we just plug in according to the formula. Sine alpha times cosine beta plus cosine alpha times sine beta. That'll be square root of 3 over 2 times square root of 2 over 2 plus 1/2 times square root of 2 over 2. And once again, don't forget, if you don't have these relationships committed to memory, then use your unit circle, use that chart that I gave you for the special angles. So that you're not throwing just any old thing in there. Then you go ahead and multiply square root of 6 over 4, square root of 2 over 4, add them together, square root of 6 plus square root of 2 over 4. All right. Questions before we scroll up, make sure we're okay. Anybody holding on? Mr. Red. Okay. Suppose that sine alpha is 12 over 13 for a quadrant 2 angle alpha, and sine beta is 3 over 5 for a quadrant 1 angle beta. Find the exact value of each. And we have some, okay. They ask us A is cosine alpha, B is cosine beta, and C is cosine alpha plus beta. All right. So first thing we'll do is find our missing sides. And don't forget, we have two different angles here. Sine, we got alpha, and then we have beta. And alpha is in quadrant 2, beta is in quadrant 1. So we're going to find the missing sides in reference to each angle individually. Of course, let me know if I'm scrolling up too far. Oh, these are sine, right? Yep. So in the purple, just making sure we remember that sine is y over r. So when we look at it first, our relationship sine alpha is equal to 12 over 13. Y is 12, r is 13. And we need to find x. Everybody holding on to that? Can I go all the way up to the green? All right, there we go. So we need to find x. So we do our distance equation, x squared plus y squared equal to r squared. Plug in y and r, x squared plus 12 squared equal to 13 squared. 12 squared is 144, 13 is 169. Subtract 144 to both sides. That gives us x squared equal to 25. Take the square root of both sides. That gives us plus or minus 5. So don't forget, whenever you take the square root of both sides to solve, that's plus or minus. Now, what dictates whether we use the plus or the minus, positive or the negative 5, is the quadrant that we're in. So we're in quadrant 2. That's over here. I'm talking about over here. We're in quadrant 2 for alpha. So that means x is going to be negative in quadrant 2. So that means x is going to be negative 5. Make sure we're okay with that. All right, let's go to the next one. Well, since they asked for A was cosine alpha, we can go ahead and find A. So it's just be negative 5 over 13 because that's x over r. So we just found x. So that's x over r, negative 5 over 13. Now, when it comes to angle beta, we have to do the same thing we did for angle alpha. Find x. Don't let me scroll up. Anybody still copying that stuff up top? Good, everybody good. All right, so do the same thing for angle beta. We had sine beta. Your sine dictates that you have y over r. So that means 3 is going to be y. R is going to be 5. We need to find x. Plug it into your equation. So that's x squared plus y squared, well, x squared plus 3 squared equal to 5 squared. 3 squared is 9. 5 squared is 25. Minus 9 from both sides give you x squared equal to 16. Take the square root of both sides. X is equal to plus or minus 4. Now this time, x is positive because we're in quadrant 1. And so that'll be a positive 4 for x. So cosine beta is what we need to find for b, what they asked of us for b. That's x over r. That'll be 4 over 5. All right. So C asks us to find cosine alpha plus beta. So that's going to be cosine alpha, cosine beta minus sine alpha, sine beta. And we have our 4 pieces now. Cosine alpha, sine alpha, cosine beta, sine beta. And we plug them in. All right. So it's negative 5 over 13 times 4 over 5 minus 12 over 13 times 3 over 5. Negative 20 over 65 minus 36 over 65. That'll give you negative 56 over 65. All right, questions, any questions? Oh, there was a D. Did I put D up here? I want to put ABC. Okay, we could do D though. No big deal. I just know I didn't see D. All right, so if we have sine alpha plus beta, you just follow in the same format, just using the formula accordingly. So that's sine alpha times cosine beta plus cosine alpha times sine beta, 12 over 13 times 4 over 5 plus negative 5 over 13 times 3 over 5. Multiply that out, 48 over 65 minus 15 over 65. And that'll be 33 over 65. Any problems, any problems? All right, so last two, I believe, in this section, the sum and difference formulas for tangent. So tangent alpha plus beta is tan alpha plus tan beta over 1. minus tan alpha, tan beta, and then difference, same setup, just that you switch your plus and minus signs. All right, so we want to verify this one. Tan of x minus pi over 4 is going to be equal to tan x minus 1 over tan x plus 1. So x is going to be alpha, pi over 4 is beta, and we plug it in according to our formulas. So that'll be tan x minus tan pi over 4, then 1 plus tan x, tan pi over 4. And tan pi over 4 is just 1. So that's tan x minus 1 up top, and then 1 plus tan x times 1 down bottom, which is just tan x, of course. So tan x minus 1, 1 plus tan x is the same thing as what we were looking for. That's all you had to do there. All right, questions, any questions? All right, that's not this. Before I go any further, is everybody okay? Scroll up, everybody good? All right, let me see. Do I want to jump into 6.3? Let's do this. How many more of these do I have here? Just looking at some stuff. All right, so this is what I'm gonna do. I'm gonna go through a few more problems of 6.1. From 6.1, just verifying, just making sure we're okay with our different options that we have. I'm probably gonna pause on doing 6.3 because I don't want to rush through it. You see that we only have 4 sections out of chapter 6 anyway. So I don't want to just rush through some stuff. So let's do a few more problems out of 6.1 just to get you guys in that flow. So here we have sine theta over 1 minus cotangent theta minus cosine theta over tan theta minus 1. And that's equal to sine theta plus cosine theta. So once again, we want to prove that the left side is equal to the right side. So you notice what I have here. One note or one option that you have here is to multiply top and bottom of the fraction by the conjugate of the denominator. Remember, conjugates is just changing that middle sign. So what I did was I multiplied top and bottom by 1 minus or 1 plus, excuse me, cotangent for this one. So I'll let you write that for those who are writing. Because we got to figure out a way to simplify this in such a way that it's just equal to sine plus cosine. So multiplying top and bottom by the conjugate of the denominator. So that first one, I'm going to multiply top and bottom by 1 plus cotangent. Second one, multiply top and bottom by tan plus 1. So here, 1 minus cotangent times 1 plus cotangent. If you follow that out, see our middle terms cancel, and that'll leave us with just 1 minus cotangent squared. All right. So that first fraction turns into this when you multiply both top and bottom by it. So that numerator, distribute the sign, that'll be sine theta plus sine theta cotangent theta. And it's over 1 minus cotangent theta. So then I rewrote this cotangent as cosine over sine. Sines cancel, and that simplifies to sine plus cosine over 1 minus cotangent squared. So that's just my first term. All right, so like I mentioned, for the next one, you multiply top and bottom by the conjugate, which is tan theta plus 1. I'll scroll up and somebody still copy and let me know. So that numerator is going to be cosine times tan plus cosine. Then the denominator, your middle terms cancel, those two tans cancel, and that'll be tan squared minus 1. Rewrite the tangent as sine over cosine. Cosines cancel. That gives me sine plus cosine over tangent squared minus 1. And so this is our second term. All right, scrolling up. All right, so this is what we have so far. Right there. Hold on 1 second. Trying to see what did I do that. Did I write the rest of the problem? Got 1 plus cotangent, 1 minus cotangent. Plus cotangent, cosine. Yep. My square. But where did my square go? Hold on, y'all. I'm missing my squares right here. I'm trying to figure out why I don't have my squares anymore. That should have been 10 plus minus 1. 1 plus, 1 minus. So that's right so far. I'm gonna have to do this one over. Combine. Right, that's fine, that's fine. Let's switch to the other side. Oh, I got what happened here. So I should have wrote a better note than that. Okay, so I see what I did here. So what ended up happening here, this is one of the ways or one of the methods that you could have in going about trying to simplify. But what ended up happening is that it started to make this more complicated than what we needed. We start going in a different direction. Remember, we were trying to simplify this and we were going less simple. You know, it was going more complicated. So I paused and came back and went back to the original problem. And so remember I told you last class, I think this is what happened when somebody asked me this question. So this is what sometimes when you do these problems, what ends up happening is you start a certain way and then you end up recognizing like, whoa, I need to back up, I need to stop. And so those are a lot of times that's where you learn a lot from. So what I ended up doing here is looking at that, going back to the beginning. I guess I should write myself a better note for the next class, right? Let's see, original problem. So you go back, I decided to rewrite my denominator in terms of sine and cosine. So that's what I did here. 1 minus cotangent is cosine over sine for your cotangent. Then I wanted to bring together as one solid fraction. So I rewrote 1 as sine over sine. So the sine over sine minus cosine over sine. And that gives me sine minus cosine over sine. And then do the same thing for tan theta. And so that'll give us a sine minus cosine over cosine. All right, which one? Oh, right here? Yeah, it should be a theta. Yep. Yeah, because they don't stand alone, so they have to be applied to something. So yep, you're right. So these are my new denominators. So I got that one right here, this one right here. And so to get rid of this sine and this cosine, I multiply top and bottom here by sine, multiply top and bottom here by cosine. So now we have sine squared over sine theta minus cosine theta minus cosine squared over sine theta minus cosine theta. Bring them together because I have the common denominator. And now I can factor out that numerator as the difference of squares. Difference of squares is x plus y, x minus y. So that's why you have sine plus cosine times sine minus cosine in that numerator. Now the sine minus cosine cancels, and it leaves me with just a sine plus cosine. All right. Say again. Yep, it's algebra. Yep. So your classmate had mentioned, once you get past the trig relationships, then after that, it's just algebra. And that's pretty much where, and I'll say this too, as a, I won't say warning, but something to pay attention to going forward, especially if you're going into calculus or whatever. That's the foundation of all your sciences. Any of your upper level maths, any of your sciences, algebra is it. I think I told pre-calc class last semester that, only really mention that because I got a few in this class. I have a calculus problem that's like 7 pages long, but the first 2-3 steps are calculus, and then the rest is just algebra. I had a student that told me, took calculus with me 2 semesters ago. And he said this is his second or third time taking it. And he said his last teacher told him, he said, you didn't fail calculus, you finally failed algebra. So the algebra piece is very key to your success moving forward. And, all of this playing around with stuff and moving stuff and solving, getting down to here, realizing it's getting more complicated than we really want. All of that was the algebra, so you do want to make sure that you are okay with your algebra. All right. So I think this is just a problem that somebody asked me before. So it's worth going through and seeing how you can start the problem, with the regular way. End up getting stuck. Remember I mentioned that last class, and then you have to go double back and try another way in order to get to your answer. But if you get stuck, that doesn't mean that it doesn't come out to verify. It's just that you need to figure out another way to get there. All right. So before we close out, questions, concerns, comments? Everybody good? Everybody straight? All right. So if you guys are good, I'm good. I will see you next class. Have a great weekend. Enjoy the Super Bowl for those who are gonna watch. And we'll get into 6.3 next class. Well, yeah, 6.3 next class. You guys take care.
Bye.
Thanks.
Thank you very much. Goodbye.
Take care.